Welcome to this illustration uh, of demonstrating how to do a Helm-based installation on an Oracle cloud infrastructure, Oracle Kubernetes engine, in short OKE, when a customer pushes their artifacts, the Helm artifacts, into OCI artifact repository. So to break it to three parts of this illustration, Um, we are going to use Helm chart for this, which would help us to do a templatization over Kubernetes artifacts. Second thing, we will be using a function that will connect between the artifact upload event using OCI Service Connector Hub. And at last, we will be using the OCI OKE to do a deployment. A little bit extra, the whole interaction is sort of under a private subnet. So everything is using a private subnet. So I'll be sharing the link and the detailed flow diagram after this presentations, so that if you have further questions after the sessions, to take a look. So let's go back and start the procedures. I'm logging into the Oracle cloud infrastructure, and we assume you have all this access in advance. And I'm also using Cloud Shell a lot. So I'm just launching my Cloud Shell machine, which is pretty cool. And we have done certain things in advance to save some time, but we're gonna see everything in details. Okay. So what we are trying to do here is we are trying to do two or three major things. One is an artifact repository, second one is functions, and third one is Oracle Container Engine. Okay, so the first thing that we're gonna do, we're gonna create some dynamic groups. So dynamic groups is a pretty cool concept in OCI, which would help us to refer a bunch of resources based on the resource types or based on certain other selection criterias. And as and when those resources are getting added, it will get referred by the DG. And we could use the dynamic group to have some further policies. So for example, we're gonna see two major dynamic groups here. So first thing I'm gonna do is we're gonna create some dynamic groups. So you click create dynamic groups. So the first thing I created is for the functions. So what are these functions? I give a name for these dynamic groups, and you're gonna create two rules. So the first rule is resource type is function, FN function, and the compartment that I'll be using, the OCD of my compartment. So any function that is created under this compartment can be referred using this dynamic group. So similarly, there is one more dynamic group which I'm using for the artifact registry. Pretty simple. I'm gonna use another rule where we say, hey, my resource type is artifact repository and my compartment is this. I'm gonna give the OCD of this compartment. So the first step is create this dynamic group. The second step for this procedure, you would see everything step by step in detail when I share the link. But the second thing that we're going to create some policies. What are these policies? We need some policies for the functions to have an access on Oracle Kubernetes Engine. The functions should be able to read the artifact. And that is another policies to connect between the service connector hub and the functions. So we're going to see these three policies. So the first policy is a policy that would help for functions to access Oracle Kubernetes engines. I'm going to say the dynamic groups, whatever I create for the functions to manage the cluster family in my compartment. Pretty straightforward. Now the policy is for functions to read the artifact. Again, I don't want to modify the artifact or upload the artifact from the function. Rather, I just want to read the artifact, which I'll be using for Helm deployment. I'll say the same function group will have an access to read all my artifact. Um, just a little bit, we'll be using functions with the resource principal method so that the functions can use OCI CLI or the Python SDKs eventually to have access on these resources. The third policy is, now it's not necessary to create this policy at this stage, because when you create the service connector, it would help you to create it, by itself, or you could create one in advance. So here it's a little longer policy statement, but basically what I'm trying to say, I'm saying any user to use the functions in my compartment ID, and I'm going to use the principal type as service connector, and the principal compartment ID is my compartment ID. Now, why I'm using this is basically the service connector hub is trying to integrate between an event when I push something to artifact repository, and invoking the functions. Now, don't worry about this policy, because if you don't create this policies, basically will create when you create your service connector hub. So this is more as an optional for you to create at this stage. So we have the DG, we have the policies, we are all set to go now. So now next thing is we're going to create the artifact repository. So one of the use cases here we are trying to cover is, let's say the customer has an external CI, continuous integration, and they do everything on their premise, and they just push things to the OCI Artifactory, and we will pick it from there, and we're going to use a private OKE to deploy and take it further. And obviously using Helm artifact. So first thing first, go to artifact registry. I will say create artifact. I give the name. I can select the compartment description. Again, there is one important thing is immutable artifact. Depends on the use case. So if you select immutable artifacts, which means you cannot change the function, the version, even if you delete it. So for example, you have a version 0.0, you cannot overwrite it. So if you don't want to do that and you want to overwrite, you can just unselect this. But this is completely up to the user to decide. Okay. And once you have the artifact repo, make a note of the OCID of it. Okay, we'll be using this eventually further. So our artifact registry is also ready. And the next thing is where we're gonna put this application, which is Kubernetes engine. I love this part. I'll appreciate you to take a read on the documentation. You have multiple feature on the Kubernetes engine. But we're gonna create Kubernetes engine in two ways. So you can actually create using kucreate, which means it will help you to create everything by itself in one click. It'll help you to create all these resources. Or you could create a custom resources where this wizard will help you to create cluster in the node, and you have to feed in all the information, like you want to use a VCN, virtual cloud networks, and you want to give whatever information which you have already created in advance. So it's again your choice. In this illustration, in the procedure that we're gonna give, I'll be using kucreate. So we're gonna launch a workflow. We give the name of the workflow, and we're gonna select private endpoint and private workers. As I said, this is completely a private setup, and you could change, give it as E3 flex or E4 flex, or we could use another one if you want to use this for a bigger workload. Depends on this. Refer your documentation for more of that. Yeah. And that's it. It'll create a cluster for you and wait for it to get active. It'll take a while, and you'll see all this information, and you could see, a node pool with three nodes been created for this, and it is span in different availability domains. So we are pretty lessly, and you have all this information available for you. Okay. Again, the point I will reiterate: if you want to use your own VCN, feel free, but make sure that if you really want to see the essence of it, make use of private endpoint and private worker, so that the traffic will be completely inside the private subnet. Now that we have used the Kubernetes cluster quick launch. So if I go to my virtual cloud network, or in short VCN, I'll see a VCN created by the OKE workflow. So I'll see an OKE VCN with my compartment name and some ID and the name of the cluster. So as a beauty, because it's created by itself. If I go it, I'll actually see subnets and all those necessary resources. To get a little here, so there are three subnets. One subnet for the endpoint, another subnet for the private, again one subnet for the endpoint, one subnet for the load balancer if you use service load balancers to expose your services. You'll have another one for your node subnet where you have the node pool. Now, in this illustration, we'll be using the same subnet to build up instance to test something, to build the functions inside this, so that the whole communication remains the same. But it's absolutely not necessary. You can have any other private subnet within the VCN, or you can take it from another VCN if you have a kind of a DRG, which is called Dynamic Routing Gateway, or local VPN peering, or regional VPN peering. It's completely up to your selection. But in this case, we are not doing more complex things. We are just keeping it simpler, and we are saying, hey, take one of this subnet and create stuff. So it's in the same subnet. Again, a private subnet. Okay. So I'm going inside my node subnet. So if I go to my node subnet, which is a private subnet, I'll see a security list. So I click on the security list. Okay. And I'm gonna say because I eventually create a VM here, and from the VM I'm gonna try to access the endpoint. So I'm gonna create a small rule here, which is an ingress rule, and I'll say, hey, my CIDR is a source inside my VCN anywhere. Protocol is TCP, and the port that I'm going to use is 6443. 6443 is the port that will be used for the Kubernetes API endpoint. So you have to add an ingress rule for these things to work. The second thing is, let's go back to the VCN that so we'll be using a sample application, a Python applications, and we want to use this through a load balancer. So it's completely again up to the user to decide what they want to use it. They can have many ways to expose the application. We are using a load balancer, so we're going to add a routing for this. Why we need a routing? Because the whole stuff is inside private segments, so private endpoint Kubernetes, private worker Kubernetes, and public load balancer. So we are using an internet gateway. Again, the beauty when you use create workflow, it will create an internet gateway for you. But if you don't want to use this, you could use an internet gateways or service gateway if you completely want to use a private load balancer. I've given all those references and pretty self-explanatory. But let's look at what is this route table here. So basically, I'm going to say my target type is internet gateway. You have multiple type of targets here. And I'll give my CIDR block, and you will see a internet gateway is created as part of the Qt workflow. So I'll select that, and I'll say, hey, submit this. Okay, so that's pretty much the OKE part for me. So I create the OKE, I go to the VCN, update the subnet for node to allow 6443. Then I come back and create a route table for the OKE load balancer to have an access from the internet. So let's go back to the second part, which is functions and applications. So as you know, we go to the applications. First thing, you create an application, create applications, select the appropriate VCN and select the subnet. So again, ensure to select the private subnet. And as I said, we're going to use the node subnet, which is created by the Qt workflow. Or you could use another private subnet where you think you have the right access has been provisioned. And yeah, that's it. You just create an applications. Okay. And now we want to access these applications from either your local machine or a cloud shell. And you have a pretty straightforward procedures updated available via getting started. So use one of them. So I've used my cloud shell. So I go to my cloud shell. I've created a folder here. So if I my fn list apps, I'll actually see my applications that I've created for this. How did I get this? Because I executed all these commands. Again, there is one point I have to provide my Docker login. So this is basically your login, your federated login, or your credential that you'll be using to push things to your Docker, which is basically the container registry provided by OCI. Okay, so make sure that you provide the right access. And once everything is ready, you have the list applications is ready. So now let's go back to this the repository that we want to clone, because basically this repository, we have two repositories available in the public gate. One where you have the function definition, other one is a sample applications like a Helm chart and Python applications. But in this one, what do you have? You have func.py. We are using a function Python SDK here, okay, which would help you to do I don't go much deeper, but simple thing will help you to have identify which artifact repo got updated and what's the path and informations. And then we're going to use an Oracle Cloud deployment. Okay, so we'll be using Oracle Cloud OKE deployment. Okay, using this. Another important thing is we are using OCI Python SDK here. Okay, for all these actions, how we are doing this. We are making Python SDKs with a self-signer and using as principal resource principal authorization method. So we are using all these resource principles and creating a signer, and using the signer we are invoking this because the function is in the compartment of the user, so it's pretty simple to consider it as a resource, and we have given the dynamic group and the policy for the function to access artifact and OKE and eventually the service connector hub. Let's go back. What we're gonna do is, so let me see. You have this. So we have updated the clone of this. So I'll show the procedures, and it's pretty easy to understand. So we built this one. We updated VCN, and we have this state. So we're gonna clone this repository, and we go inside this folder. Okay, and so let me go inside the folder, and you would see the necessary thing that we want to do it. And we're gonna do an fn deploy and a name of the functions. Okay, so in my case, I'm using a function name as you know a function a happy Helm chart. So where can I see that? So there is a file func.yaml. So you have to update two values in here. Again, this is pretty straightforward procedure. One, you have to update the OCI region. So I'm using this demo using Frankfurt, but you could use another region, and the cluster ID, because this is important for the function to identify on which cluster that I want to act on. Okay, and then once it is ready, you're gonna do an fn deploy. Okay, so you will see fn deploy -v the application that we have created just a while ago. So that's it. So once it has been successful, again, provided you have given your right Docker username and password. If not, you would see an error saying that unable to access the repository and so on. So things is pretty easy. But if everything is fine, you will see a function entry here, and you could see the image that has been built based on the Docker file, because you have built a Docker file. And if you see that inside the Docker file of these functions, maybe that's a little bit, I'll show you. Apart from the regular Python path, we are actually installing the Helm. So we'll be using Helm for the deployment because the artifact that we get is a Helm chart package. All right, so the function is ready. Again, don't forget to enable the logging. Go to the applications, enable the logging. It'll be disabled at the beginning. Just toggle the button and give a log name and log group. And this is important for us to see in case if there is an error, or even if there is a success, to know what's happening if you don't want to use Bastion and things. Okay. So now that's been done. Then the third major part. So now we have the function, we have the OKE, we have the artifact repository. So how do I connect all these things together? So I'm gonna create something called service connector. Okay, so it's a service connector hub would help us to interface between two different entry. You have a source. You could actually a task. We are not using any task here, so we want to do some manipulation in between, and then I have a target. So my source is logging, target is functions. Okay. So initially you could, so don't go to the advanced mode if you don't want. So let's use this the drop down, pretty easy. So you say in which compartment, and you're gonna use the audit logs. Why you need the audit log? Because when something uploaded to the artifact, you will see something in the audit log, and it'll say what are you gonna see, an event type, and from where it is coming. It's coming from the artifact registry. Okay, because that's what we are targeting. Yeah. And what are the different events? So you can say, hey, somebody update it by path, somebody upload it by path. So there could be many ways. Somebody can use the UI and just say upload upload an artifact, or somebody can upload it using OCI commands, using a generic artifact, or update by path. So we use those things. So there is the artifact, generic artifact, update. Somebody can modify it also. And now we know anything that happens for the artifact registry, the function will be triggered. Okay, and here there's a tricky part. If you do this, it's like an open bar situation. Anything that happens with the artifact, your function will be invoked. So you don't want to do that. So you could use another attribute, pretty easy. In our case, we are going to use the source type. Okay. So what does the source indicate? So when I upload something to the artifact, maybe I'll show you that. And at the beginning, you will not see this, but just to give you the right context, let me go to the artifact repo. It's artifact registry. Bring this down. If I go to the artifact repo, you see different artifact. You have a name, you have an artifact path. So this is what we are referring. So in our case, we are assuming you have one artifact, okay? And this function will invoke when I identify certain path in my artifact. So I can say, if you see something like sample fast API, okay, .zip. So I'm using a wildcard, okay? Invoke the functions. So if you have a good and the correct wildcard, and you have tested a good log, you would actually see this. At the beginning, you will not see any logs because you have not done any action. There is one more better way, because if you have multiple artifact repository in the same compartment and you want to use many of those things based and to invoke functions, maybe you could have another artifact where there will be another function named sample fast API, right? So the easiest way is you could, instead of source, you could do path. So there is another attribute which is called request path, okay? And in this request path, you could actually say star and give the OCID of this repository. So I would say this function will invoke for this artifact, okay? So let's say you add this, okay? And then you add one more attribute, and this attribute you will say my source is star sample fast API. So what I've basically done is, instead of giving a very generic name as sample fast API, then you will see anywhere in the artifact repository inside compartment, if there is an application artifact called sample fast API, and if that get uploaded, the function will, we don't want to do that. So we're going to restrict this to a specific artifact ID, which is what we want. And we are using a source one, okay? Then what we do, we're going to select the compartment and the application that we have created for the functions and the name of the function, and just say save. That's all. And yeah, it will come like an advanced query if you want to use this, or you could use the basic wizard and select it. So your service connector is ready. So you have the function, you have the OKE, you have the artifact, you have your service connector, everything is ready, okay? There is an option. So to do so, you need to create a bastion. So you click create bastion. So basically you create the bastion, select the VCN that we want to do it, select the subnets. So you can have multiple subnet, but I'm gonna select the subnet of my node subnet. Okay, and this is my subnet. Oh, sorry, you can have only one subnet, but you can have multiple CIDR block from which the bastion can be executed. So I'm gonna say, hey, anything that that comes in, just accept it, because this is a secured way. So I don't really worry much. I'll say that, and I create a bastion. So my bastion is ready. And once the bastion is ready, you're gonna create something called sessions. Basically, what is the session? So session will help you to have a secured tunnel between your local system or wherever you are trying to use this to the entry point where you will be accessing your private instances. So I'll give you a session name. I'll say Helm host. What is this? My Helm host. I just give a random name. And I select my okay. So there is one part. So Before I do this session, I need to create an instance. Okay, so I go to instance because I'll be using that as my gem host. So I go create an instance. So I create an instance, and I used in the same subnet of my okay node subnet where the functions also reside or the applications also reside. Another part is ensure that you go to Oracle Cloud Agent, ensure your Bastion is running. Now, sometimes what happens, you have a private instance, and from a private instance, you probably don't want to have or you don't have an access to the public EM repository. So when you create an instance, you go to the advanced options, okay? And you could actually use an inline script to execute things. So this is also mentioned in the procedure. So let's say we have used, I think, CentOS machine for this. Yeah. So if you are using CentOS, there is an object storage and the OCI, and you could use the object storage to install it. Or you could use your internal artifact and install the cloud agent. But why is important? You need to have the cloud agent Bastion running. That would help us to have an active Bastion connection to the VM. Okay. So let's go back to the Bastion. I create this Bastion forwarding sessions. I select my SSH key, whatever I want, and I give it and I click create session. Okay, it would take a while. Okay, and normally the default timeout is 3 hours. So once the session is active, you go to this 3 dot, copy the SSH command. Okay, so let's go and open a window. So let's say I open a terminal on my machine. Okay, I go to the path where I have my private key. So I've used the public key for my VM and public key here. I need a private key to access it. So from there, I'm gonna paste this and I replace this private key to my private key. You can execute from anywhere, but you need to provide the private key path. The local port, this is the port that I'll be using to do the local port forwarding. So I'm using port number 8080. Again, if your connection is successful, you won't get any message here. So that's not an error, that's actually behaving as expected. Okay, so I open another window and let me change the color a little bit to differentiate. So I go to the same paths and I have the key. I'm gonna see the regular SSH command with the and localhost. I'm using the instance that we have created here, the jump instance, as a localhost for me to connect because I already established my trusted Bastion connections in my other terminal. Do not close this. If you close this, this will not work. And I'm going to use my port number 8080 because in my command I use port number 8080 for the local forward. So I click this and you could see I'm inside my private host. Okay. All right. So I'm going to root. I'll stay a while there. Okay. So that's what we are talking about, the Bastion, how to do the Bastions, and then how to create the port forwarding, and you have inside this. Okay. And once you are inside the Bastion, now why we use the Bastion? We use the Bastions to see what's happening on the cluster because some point if you have an error or you want to see what's happening on the cluster, you need to use some kubectl commands or Helm commands and things like that. So, and this is a private OKE, so it's not pretty easy for you to use from the Cloud Shell. So you need a host in the same segment, and that's a private subnetted host, so you're using a Bastion to use it. Why come back to this portal? Because here you have something called a local access. How do you access this cluster from a machine? So you need to have an OCI CLI. The procedure pretty straightforward, and you need to copy paste all these commands, and you get your kubeconfig, which will be eventually using for your kubectl and Helm commands from a machine. Okay, not from the function, but from a machine for us to do some troubleshooting. So that's what I mentioned here as well. Now, you may have a question like, how do I install kubectl? How would I install Helm on the machine? So I've given some link. Normally, if it is allow you to connect from this link, it would help you. Or if it is completely uh, you know non-exposed zone and it's a private machine, maybe you have to do a local installation. This procedure will help you to download it somewhere, upload it to a local artifact, or or an S3 object, or maybe using another method like a file share and sort of things, and you need to install kubectl at least so that you can interact with the cluster that we created, basically the OKE. So in my case, I have my kubectl and I have my Helm also installed. So let me use my kubectl and I'll say get nodes. So I'll see all those 3 nodes that are available. So which means it's okay, everything is fine for me. I don't need to worry about it. Okay. So that's what we have mentioned here. Okay. So now all these things are ready. We are good. We have the OKE, we have the artifact, we have the functions. So now how do we test this? Because we created something called a service connector hub. So we want to test that. So let's go back to this, the Cloud Shell that we were using it. Like I said in the beginning, you have one main repo. You also have another repository where we have built a sample application. So I'll show you quickly that, and then we'll go to do the demonstration. Track. Let's see the sample application with help chart. Why we build this? Because you need a small Python file, which say hello from sample applications. And this is using fast API, pretty faster web framework for Python. And we have a Docker file because in your application, so let's look at the full flow. When you have a CI outside or using OCI, you have an application. So you return applications in whichever language. You containerize it. So you're using Docker or another method. So for that, you are using Docker file. And we have Helm chart. Why we are using Helm chart instead of Kubernetes artifact individual? We are using templatization. So just to tell you something like, let's say I take one of the YAML and you could see a lot of things are variabilized here. So you would say it's coming from somewhere, and that's beauty of Helm. And there are enough material that you could take a look at in the internet to know more about Helm. Just to give you could actually parameterize, and you could easily manage a bunch of Kubernetes artifact. But that's this repo. So you have to clone this repository. So you're gonna do a sample test here. So where is it? So we built the Bastion and all these things. We cross all these things. Now we're gonna let's test this. Where is it? Yeah. So we're gonna clone this repository. So I go back to my Cloud Shell. So I go to my so I go one step before, and I'll show you. I've already cloned it. So that's my sample Helm chart, and here I have my Helm chart and my Docker file. Okay. So 2 things we have to do. We have to build the Docker things and push to the container repo. Okay. So that's an actually application container artifact, and then update something on the Helm chart, and then we trying to do that with Service Connector Hub. So first thing first, you log into the Docker. So log into your Docker URL, whichever a URL that you want to use it. Now it can be OCI container registry, or it could be outside, provided your outside container registry will be able to access, or container registry is allowed to have an access from your private OKE. If not, you need to use something internal itself. Okay, so that depends on your choice, but you need to push your container image somewhere. I'm using Docker, or you could use Kaneko if you don't want to use Docker or another tool and etc. But basically we are building an image based on the container file, and we are pushing this to the Docker URL. So once you do that, if I use Docker images, yeah, so I have built that. I put a version 0.1, and I did literally, but it's exactly the same Docker file. I did Docker build, and I pushed to my repository container artifact. Sorry, my Docker container or OCI container registry. Right now, what we have to do is, so now I have my my Docker files ready. Okay, so I need to update that in my Helm chart sample applications, and all your values will be values.yaml because you'll be using different repositories. I'm gonna use my repository, and I'll say this is my repository. I'm saying the tag. Okay, so it's pretty, again, we have put enough commands for you to understand, but if you don't use it, it'll try to use the chat version as the application. Sometimes you don't want to use the same thing. Then if you want to override it, use the tag as a version here. And you can have multiple things, service account. A lot of things are, create is true or delete is true. It depends on what we want to manage it. Okay. Now, once we have those things, next thing that we're going to create is we're going to create something called Helm Packages. Okay. Why we need this Helm package? Because the whole until Helm package, the whole thing will normally run at the customer side of the CI. Okay. And only the Helm packages. So how do I do Helm packages? If I want to do Helm packages, I will say Helm package. Okay. And I have to give the absolute path. I'll say Helm chart sample blah blah blah, and this would create a chart with a chart version basically coming from chart.yaml dot tar.gzip file, and this contains everything. The beauty of Helm is you can actually do a pretty straightforward Helm install from this tar.gzip itself. But we are not doing that. What we are trying to do is, or what we are trying to simulate here is in a scenario where we have a Helm chart outside, everything is pretty clean and ready, and somebody is now pushing this to artifact. Okay, so they can push it through UI, or they can push it through API, or they can push it through other way like SDKs and CLI. We are using an OCI artifact upload by path method. So we are uploading by path and the repository ID. Okay, that's a repository that we have created, artifact path, because this name is very important. This is what we have given to the service connector hub to say, hey, look at this path, and whatever that comes from this path, then you invoke the function. So if you don't use the right path, it will not work. And the content body is basically the tar.gz that we have done. That's all. So now we just do OC artifact and tg dots and give the path. And once you do that, so if you want to verify this action is completed, okay, let me show you. If you go to the artifact registry, okay, so I'm gonna upload it with a version. So I just want to show the artifact version is right because I've enabled immutable artifact, so if I try to use with version 12, it would give you a 409 saying that hey, this artifact version is already existing. Yeah. So I'm gonna use another version instead of 12. I'm gonna use 13. Right. I'm gonna use version 13. Again, say hey. Okay, now I use version 13. Yeah. So if I go to my artifact registry and go here, and I should actually see my stuff is available as version 13. Everything is clean and clear. Okay. But is it deployed to Kubernetes? How would I know? So there are many ways to do it. So let's go back to my gem host. Okay. Okay. So let me establish the tunnel because if you give it idle for a while, this will disconnect. So I'll reestablish my connection. I go to my root user where I've installed my kubectl, and I'll say kubectl get ns. And yes, it is working. I can actually see there is a namespace that is created with Helm demo because this is what is a namespace that I given my sample application Helm chart values.yaml, and the name of the namespace is ns Helm demo. And let me go back and see what is inside. Say and I can see all my things are deployed. So I have my ports, I have my applications and load balancer and so on, some things. Okay, I make a note of this application IP. I would need this because we want to eventually see what's coming in, right? Say if all things are working, let me go back. What's my application? My application say, hey, hello from sample application and I version 0.12. Okay. So let me try to put this on my browser. So you may have a question like you put everything in private, how am I able to access it? So I'm using a public load balancer. If you're using a Private load balancer, you need to go to a machine which is inside the VCN and try to access it. So I'm using a public load balancer just to see the demo things. It's absolutely not necessary to use public load balancer. Yeah, it is working, what we have deployed just now. In case if there is an error or if you want to see how the whole thing is happening, so if you go to the logs, since we have enabled the logs for the applications, you could actually go to the specific logs. You can go from here, or you could come from the app. I think I'll show you from there. So if you go to the applications, um, select the application that we have used for this demo, and go to the logs. Click on the logs, and you'll actually see a logs for all this function execution because we have given in-one loggings to this. So you could see, hey, there are different upgrades completed. It's trying to do with version 13, which we have recently updated, and everything is done, and it's pretty clear. And this is sample fast API.zip and this. That's the whole demonstrations using artifact hub, service connector hub, artifact repo, service connector hub, and a functions to invoke all the way from a Helm packages to an actual deployment on the OKE. And since this is functions, we are using a couple of points to note here. Since it is functions, we are using a maximum timeout here, which is 5 minutes for OCI functions. Okay, and whatever that you want to do it, you could use it within 5 minutes. Sometimes you will have some sensitive information that you want to send it from a vault. So for instance, you want to send some, let's say you don't want to give your container artifact or container registry as public, you want to use it with the credentials. So how do you use that? You use that credentials at your vault. Okay, I'm using another func.yaml, but that's exactly the same. You could actually provide the OCD of the vault inside the functions, and this value would be used as a local variable for your function. So you could actually pass that for a Helm with values. Of course, you need to provide a dynamic groups and policy for functions to read and write these secrets. I'll again give you this link so you can actually refer to that. So that's pretty much around today's demo of using Artifact Hub event and to invoke functions and then deploy to OKE use Helm. So if you have any feedback, suggestions, questions, issues, feel free to create an issues or suggestions to the GitHub repo, and we can take it from there. So thank you for your time, and we much appreciate that.